So what we're going to do today is determine the distance between 2 points in the coordinate plane. So let's go to our first example. We want to graph the 3 points 2, 3, 2, 6, 6, 6. So we have 2, 3 here, that's A, 2, 6 there, and 6, 6 there. Okay, and now we want to figure out the distances between these points. Okay, so if you take a look at the first question, it says, what's the distance between line segment AB? Well, it's very straightforward. It's 3 because you just count 3 units. It's a vertical line. Then BC, it's 4. You count 4 units. Now, how do you find the distance of the diagonal? Well, that's a little trickier because you can't count diagonal distance, but you should see that a vertical and a horizontal line form a right triangle, a right angle forming a right triangle, and you can use the Pythagorean theorem to do 3 squared plus 4 squared equals c squared. And you should then see, because we've done a number of these, that we have a Pythagorean triple, so that c is 5. So, how do we determine or do this? To find the length of the diagonal, you need to use the Pythagorean theorem. Okay. So let's go on to some other examples. Now I just give you 2 coordinates, 3, 0, and 7, negative 5. Right? So 3, 0 is there, 7, negative 5 is there. So I want the distance of that segment. So what's a good strategy to use here? Well, we can't, again, count from those 2 points, but we can create a right triangle. Now, why is that helpful? Because we now know that this is 4 units, this is 5 units, and now we're trying to find the hypotenuse so that we can do 4 squared plus 5 squared equals c squared. Now we're just doing the math. Since it said round to the nearest tenth, we get c is 6.4. Okay? Let's do the next one. Our 2 coordinates are 1, 3, and negative 2, 4. So it's this line there. So we create our little right triangle. We've got 3 units there and 1 unit there. Again, we're trying to find the diagonal. And so we get 3.2 is equal to c. Okay. Now, let's take a look at example number 4. 2 cars leave a house in which one is located at the origin. Okay, let me just adjust this. One of the cars travels 8 miles north, so that means it goes up 8. Then 6 miles east to the right, here. So that's what this car did. The second car travels 10 south and 9 west. So that's what this car did. So one car is here, the other car is here. And we want to find that distance. Okay? Now, there's a couple of different ways to do this. One way is to find for each triangle, this one and this one, C, okay, which will give us the length of each hypotenuse, and then add those together. So let's just do that one. So that means I'm just going to shortcut this. So that means this diagonal is 10, and this diagonal, because this is 10 and this is 9, and so this is 13.5, so in total, 23.5 miles. Okay? Now, another thing you could have done is you could create one huge right triangle going from here to here. Find the length of that hypotenuse, and you would see that that's 18, which is this 10 and that 8, and this is 15, which is this 9 and this 6. So you could have just done 15 squared plus 18 squared equals c squared and figured it out that way. Okay? Now, the distance formula shortcuts all of this for us. Okay? And the distance formula is the square root of x1 minus x2 squared plus y1 minus y2 squared. Okay? So the distance formula is really just a simplification of the Pythagorean theorem. And if we were to use the example above, okay, let me just go back up here for a moment. You'll see that this coordinate is 6, 8. This coordinate is -9, -10. So if we were to plug them into our formula, you'll see the math is just like the large diagonal formula. So we would do 6 minus a -9 squared plus 8 minus a -10 squared, and there we would be with our 15 and our 18. Remember, when you're dealing with square, each one, remember when you're dealing with distance, distance always has to come out to be a positive number. So you should not be getting a negative distance. So again, what we did today is we found distance on the coordinate plane by using the Pythagorean theorem.